section 8.1, it's all about polar coordinates. So previously we had worked in the rectangular coordinate system. Now we're going to start working in a polar coordinate system. I'm going to discuss that as this section goes on. So first thing we want to be able to do is plot points using polar coordinates. Then we need to be able to convert from polar coordinates to rectangular coordinates. We need to also be able to convert from rectangular back to polar, and then transform equations between polar and rectangular forms. So let's get started. So in a rectangular coordinate system, right, a point on the plane was represented by a pair of ordered numbers x, y, right, where x and y equaled the signed distances at the point from the x and y axis, right? So here we had the point x, y. In a polar coordinate system, we select called a point called a pole, right? The pole is kind of like, it's going to be the origin. That's what it's going to be. We select a point called a pole and then a ray with its vertex at the pole, and we call that its polar axis. A point P in our polar coordinate system is represented by an ordered pair of numbers, r, theta, and where where r is the distance of the point from the pole, right? R is the radius, and theta is the degree in radians. It's really important to leave it in radians, formed by the polar axis and a ray from the pole through the point, and we call these the polar coordinates. So instead of like before, when I was working on a rectangular plane, right, I'd have a point, let's call it the point like 3, 3. That's an xy. I could convert this to polar coordinates by figuring out the distance of this length and the angle theta. So I'm going to figure out the distance and theta. So if I have the point when x is 3, y is 3, I want to figure out that length. Well, I'm going to have to use the Pythagorean theorem, right? This is when x is 3, y is 3, so we've got two heights of 3 and 3. So that means my r squared is x squared plus y squared. R is 9 plus 9. R squared is 18. So R is the cube root 3 squared of 2 would be our R. And then we can go ahead and calculate our theta. Well, this is our theta here, and I know my y and my x, right? So we could take the tangent. Tangent of theta is 3 over 3, so tangent of theta is 1. Well, where is tangent of theta 1 in quadrant 1? Well, that's when theta is pi over 4. So this point could be represented in rectangular coordinates by the point xx, but it also can be represented in polar coordinates by the point r is 3 squared of 2, and theta is pi over 4. And we're going to talk more about plotting polar coordinates and how to convert between polar and rectangular coordinates as this section goes on. So here's our polar grid versus our coordinate plane, right? Both of these define the same point. You can kind of just think of it maybe as writing it in a different language, like we're translating from English to French. Actually, technically, because Rene Descartes discovered the rectangular coordinate plane, we'd be translating from French to Italian, which was discovered by Bernoulli. Bernoulli found the polar grid. Complete sidebar. So let's go ahead and plot points using polar coordinates. So R is, the first coordinate is my R, and the second point is my theta. So if I want to plot the point 2, 4, pi over 3, I'm going to go to distance of 2. That'd be right here, right? And then I want to go to 4 pi over 3. So the point is this point, right? This is when x is 2, and theta, not x is 2. This is when r is 2, and theta is 4 pi over 3. Let's plot another example, and maybe I'll switch to a brighter color so it's easier to see. What if I have 2 negative pi over 3? So now instead of going clockwise, counterclockwise, we go clockwise. So if I go negative pi over 3, that brings me right here. So I have when x is 2, pi is negative pi over 3. Now you might be saying, Dr. Miller, what? No, this is when I have 5 pi over 3. One thing we're going to talk about as this chapter goes on is how I can have multiple representations for the same point. So yes, this point is 2 negative pi over 3, but this point is also 2 5 pi over 3. Right? Remember that these values repeat themselves every time we go around 2 pi, right? So there's multiple representations. So yeah, you might want to break out your unit circle. It's always good to have a unit circle handy. So what if I have the point when x is 2 and theta is 0? Well, that's just going to be the point right here. Sorry, not x, r. R is 2. Theta is 0.